All right, so second lesson we're going to look at for 2.1, still going to involve a little bit of what we did yesterday. We got to know how to change between radians and degrees. But we're going to use that to actually do something today. Right? And what we're going to look at today is two things. We're going to look at arc length and area of a sector. We're going to start by looking at arc length. So what I've drawn in this picture is two angles, okay? And I'll label them after with you. Okay, so I've drawn two angles. Now, when we have an angle in trig we don't know the name of, there's a certain letter that we usually use. Just like in algebra, you use X a lot when you don't know something, or Y, it's another common letter. We use this Greek letter that looks like that. Okay? It's just a Greek letter, and it represents an angle that we don't know. And that Greek letter is called, actually, does anybody know what the name of that letter is? That's the Greek letter theta, T-H-E-T-A. That's how you say it, theta. So I'm going to call this angle right there, theta. And the two rays of theta come out from the center of the circle. They hit the edge of the circle right there, and they create an arc. And I'm going to call that arc S. That's the letter that your book uses to represent an arc. And I've got the same situation on the other side. I've got an angle, but I can't call it the same angle. So I'm going to call it theta 1, and I'm going to call it the arc that the rays make when it hits the edge of the circle. I'm going to call it S1. So I got a picture of two angles and two arcs. Any questions on that picture? So the goal when we're done is to have a formula that all we have to do is plug into, and then we can find the length of an arc. So, first thing I need to mention about this is that the size of an angle and the size of its arc are directly proportional. What that means is, if you make this angle twice as big, you would make the arc twice as big as it is now. If you made that angle half as big, you would make, bless you, you would make the arc half as big. Right? Any question on that idea? You make the angle bigger, the arc gets bigger. You make the angle smaller, the arc gets smaller. That's what it means to be directly proportional. As one thing changes, the other thing changes exactly the same way. Right? So, because the size of an angle and the size of the arc it makes are directly proportional, we can set up a proportion. Right? So let's set that up. So there's lots of ways you can set up the proportion, as long as you're consistent on the left and on the right. So I'm going to start on the left-hand side like this. I put the arc on top, I put the angle on the bottom. So I have to set it up the same way on the other side when I use the other two letters. So for the fraction on the right, what would go on top? S1. And what would go on the bottom? Theta 1, yes. Now the problem with that proportion, it's correct, but you can't really do anything with it. There's too many things in it you don't know. There's 4 things you don't know. You've got to plug in a couple things you do know. Right? It's kind of like going back to yesterday. If you wanted to convert between feet and inches, well, if you gave somebody that formula right there and said, here you go, use this to convert between feet and inches, this isn't very useful. You've left 4 things blank. That's basically what we have there. There's 4 things that are missing. You've got to fill in 2 of them. Like if you gave somebody this, now they're good. As long as you fill in one side, now they could solve any problem. Like if there was 23 feet, how many inches is that? That's fine. because there's only one thing they don't know. Right? But this is what we got to figure out. We have to figure out a starting point. Question? Yes, I can. Thank you. Let's just go like this. Does that work? There we go. 1 foot, 12 inches. I can do trig. I just can't. I can't measure. So 1 foot, 12 inches. All right. So that's the thing. We've got to have this fact. Now, the fact that we pick a 1 and a 12, does that limit the number that I could put over here? Like, does 1 and 12 only work for 23 feet? No. I could make it 3 feet or 6.5 feet. Just because you picked a 1 and a 12, that doesn't limit what numbers you can put on this side. You can use any numbers you want. You just need a true fact to start with, and it can be any numbers you want, as long as it's true. 2 and 24 would have worked as well. Right? But I picked the simplest one. So let's see if we can figure out a true fact that we can start with here. So just like we supposed in 1 foot there's 12 inches, we're going to suppose something here that's automatically true. We have to let this angle be a certain size. And if we do that, we mentioned yesterday something special happens. Does anybody remember how big this angle had to be? And if it was that size that I'm asking you, the size of this arc and the size of the radius came out exactly the same. Remember that? How big does that angle have to be? So the size of this arc in red and the length of that radius in black come out the same. Yeah? 1. Yes, 1 radian. If theta 1 is 1 radian, then what happens automatically, because of the definition of radians and how they work, if theta 1 is 1 radian, then the arc is automatically the same size as the radius. And if you say why, it's kind of like saying why in 1 foot is there 12 inches? That's the definition. That's how it works. That's like a definition. If that angle is 1 radian, then the arc and the radius are equal. So now we've got a fact that we can plug in to the proportion that's going to give us a starting point. Just like the 1 foot 12 inches was a starting point. So let's fill in what we have and go from there. So this side we leave blank. Okay? We don't have anything to plug in for that. Well, it's not blank, but there's nothing to plug in. So just leave it the way it is. Now, S1 is going to be R, and theta 1 is going to be 1. So remember, the whole goal is to get a formula for the length of an arc. So let's get S by itself. What do you do in a proportion to solve it? Shay? Yeah, you just cross multiply. So we've got S times 1 equals R times theta. How about Lillian? S times 1 is how much?
Do you still want the S in the equation?
Yeah, So what does that come out to?
Like S.
S. S times 1 is just S. And then the other part, R times theta. Well, we don't know what R and theta are, so we just write R times theta. Now we've got an equation that says S equals R theta, and that's the equation to find the length of an arc. So S stands for the length of an arc. What do you think R stands for? R is the radius. And what about theta? Theta is an angle. Now there's something special about the angle. Back when we created this formula, the fact that we started with was that theta 1 was 1. 1 what? Radian. 1 radian. So that means because we assumed that it was in radians, this formula has to use radians. So this is your angle. It has to be in radians. So if you get a problem and the angle is in degrees, first thing you have to do, change it to radians. So it's like here, if you assume that you're starting with feet and inches, you've got to use feet and inches on the other side. You can't put like centimeters and millimeters. If you start with feet and inches, you can convert to feet and inches. If the fact you start with involves radians, then your formula that you use has to involve radians. You can't pick a different unit. You got to stick with the same unit. Okay. So any questions on that formula? S equals R theta. So there's 3 variables. In a problem, they'll always give you 2 out of 3. You'll plug in the 2 and then solve for the one you don't know. All right. So when you get a question, this is one way they could describe it. They could just write out the whole thing. Another much shorter way, which we'll do in the next problem, is to just draw a picture. Either way. So out of all that stuff that's written, we really just have to focus on what's important. They want us to find the length of the arc. That's the directions of the top. So it says you've got a circle with an angle of pi over 3 radians and a radius of 4 inches. That part that I read, that's really the only important part. So one thing we're going to have to be able to do is, you're going to get 2 formulas by the end of today. You've got one right there. You're going to have to decide which one to use in which problem. One of the formulas you already know, it's about arc length. The other formula I'm going to give you is about area. If you read the directions, you'll know which formula to use. Find the length of the arc. So you're using the arc length formula. So that's the first thing I do, is write down what that formula is. Can someone remind me what the arc length formula is again? Yeah, Lily?
S equals R theta.
S equals R theta. Perfect. So there's our formula. Now we'll fill in everything we know, and we're going to find what we don't know. It says we have a central angle of pi over 3 radians. Right, so Taryn, central angle of pi over 3 radians. Is that the S, the R, or the theta?
Theta.
That's the theta. Central angle. That's an angle. So we'll fill in pi over 3. And then we have a radius of 4 inches. Shadowlease, radius of 4 inches. Is that the S or the R?
The R?
Yeah, radius, that's the R. So we'll plug in 4. If you want to make it a fraction, you can. It's 4 over 1. And the directions are to find the arc. That's what we don't know. Yes. Okay, so just now multiply straight across. 4 times pi divided by 3. Now what did we just find? That 4 pi over 3 is the what? It's the what? It's the arc length. So that's a length. So we got to go back in the problem and look at what the unit of length is they used. What did they use in this problem for a length unit?
Inches?
They used inches. So we have to put inches. S is a length, R is a length, theta is an angle. That's different. Okay? So 4 pi over 3 inches, or if they wanted a decimal, 4 pi over 3, it's about 4.19 inches. You don't have to put 0.190, but if you're in machine tech, you might think of things in thousandths of an inch, so it's like 4 and 190 thousandths of an inch. But if you write 4.19, that's fine. Okay, any questions on that? Okay, so pretty straightforward. You just use the formula. Okay, this one they haven't written out a whole big description about it. They just gave you a picture. But the directions are the same. Find the arc length. So we're using the same formula. But there's something here I have to be careful about. Anyone see what I need to be careful about? If I don't deal with this first, I won't get the right answer. Yeah, Jillian?
The angles in degrees, not radians.
Right, the angle is not in radians. It has to be in radians. So off to the side, that's the first thing I would do. Before I even fill anything in, just change 130 degrees to radians. And what do I multiply by to change degrees to radians? Pi over 180 or 180 over pi?
Pi over 180.
Yep, pi over 180. Now, 130 and 180, it doesn't really reduce completely. All you can do is divide by 10. So it's 13 pi over 18. Okay, there's your angle. So let's fill in our angle. Pi over 18. And now, Mike, what's my radius?
8.
8. If we want to make it a fraction, you could just put 8 over 1. Okay, I can reduce that before I multiply it. 8 and 18, both divisible by what? Well, Jacob?
2.
Yeah, both divisible by 2. 2 goes into 8 how many times?
4.
4 and into 18?
9. Yeah, 9.
Perfect. So now multiply what we have. 4 times 13 pi. What's 4 times 13? 50, what? 2, yeah. 52. Pi divided by in the bottom, it's just 1 times 9. So last thing is just to make sure if we need a label, we put a label. What did we just find? 52 pi over 9 is the arc length. So what should we put for a label on this one? Shay? Feet. This one's in feet. Any questions on how you change that to a decimal if they wanted a decimal? Okay, so we've done a couple where they give you R and they give you theta and you find S. Let's switch it up. So now they're telling me the arc length is pi over 4 centimeters and the radius is 12 centimeters. Find the angle. Okay, so now we're finding something different. Same formula, just fill in what you know. Okay, so let's start with the pi over 4 centimeters. Jayla, where's that pi over 4 going to get plugged in?
S.
That's your S, yep. Pi over 4 equals, let's see if we have another piece of information. Radius of 12. Jacob, what letter do you think the 12 is going to go in for?
R.
Yeah, it's going to go in for R because that R stands for radius. And theta, well, that's what we're finding. We don't know. Okay, questions on just filling in the formula? Okay, now we want to get theta by itself. So how about, Noelle, how would I move that 12 over to the other side? Yeah, we would divide it. So just divide by 12. And on the other side, that's just the same as putting a 12 in the bottom of that fraction. It's dividing both sides by 12. That's gone. And what do I get for an angle? But listen. So the only thing left to do there is just that arithmetic that you see. You don't have to type anything in on a calculator or anything. Not sure?
No, I need.
Anyone help her out? What's just have to do just the calculation in the denominator. Mike? 48, yeah, so pi over 48. And that's an angle. So what's the units on that if it's an angle? Okay? That's radians, yes. Remember, this formula automatically gives you an answer in radians. If you don't want radians, you've got to change that to degrees. But this formula gives you radians. So do I need RAD? No.
So isn't it like pi, the other thing to save R?
You say it again?
Yeah. Well, isn't it if you don't put it?
Right, radians, it's invisible. You don't put it.
Yeah.
Yeah. Yep. Pretend like it says RAD in white right there. It's invisible.
This is probably a dumb question. The angle, like I know you were saying that you had to find the angle. Why
Yes.
would you still keep it in radians?
Because the problem just said to find the angle. They didn't say put it in degrees.
Oh, okay.
So if they said find the angle and write your answer in degrees, then I would have to go one more step after this and do what we learned yesterday.
So technically, to find the angle, you don't need to convert it into degrees. You can leave it in radians.
You can leave it unless they tell you to convert it. You don't have to. Now, if it was a multiple choice question and the answers were all in degrees, then you have to convert it. Yeah. Okay. Any questions on that one? So if it was multiple choice, let's 3.75. Let's say these were your choices. Pi over 48. I don't know, 12, and 3.75. And maybe there'd be another choice. But which one of those would be correct? A is correct. A is the answer in radians. Now, what if I did this? Yeah, that's what I did real quick, is I just calculated 180 divided by 48. The answer in degrees is 3.75. So now the answer would be C. Okay. Questions on that? Some people get a little confused. I would know by looking at this that they're asking for an answer in degrees if it was multiple choice, because I'm seeing the little circle. That would tell me it's in degrees. Yeah.
Now, say like you didn't have a degree symbol on A, would technically A and C still be the right answer?
It would just be one right answer. Yeah, I wouldn't have this because now there's two right answers in the same problem.
Okay.
Yeah, all the answers will be in the same units. Yeah. Right, and let's try one more. The only combination we haven't done, they give you the arc length, they give you the angle, and now you find the radius. So my angle is 36 degrees, and my radius is 13 feet. I'm sorry, my arc is 13 feet. Okay, so looking at that one, any thoughts what we need to do? Yes, first thing we have to do is change degrees to radians. If you do that, you'll get pi over 5. Right, so if you multiply by pi and divide by 180, 36 goes into 185 times. Okay, so that's from the part we did yesterday. All right, now we're ready to fill in. Kezia, what's the formula we fill into for arc length? Yep, S equals R theta. And let's fill in what we know.
S would be 13, right?
S would be the 13, yep. R, well that we don't know, that's the question, find the radius. And theta, it's 36 degrees, but you want to make sure you put pi over 5. Okay, so we're trying to get R by itself, and this time there's two numbers next to R that we want to get rid of, the pi and the 5. And we can get rid of both at the same time if we multiply both sides by something. The reciprocal. And what's the reciprocal of pi over 5? 5 over pi. So if you do that, pi's cancel, the 5's cancel, everything on the right is gone except the R. On the left, there's nothing left to do except 5 times 13. And what's 5 times 13 give me?
65.
65. Okay. And that's a radius. So do I need to put a label on that?
Yes.
Yes, a radius is a measure of how long something is. So we have to say how long it is. Feet in this problem.
And it's okay to leave it in the fraction over pi.
Yes, unless the direction specifically said find the radius and round your answer to 2 decimal places. That's the only time you'd have to round it. Any question on how to type that in on a calculator? If they asked around.
It would just be 65 divided by the pi.
65 divided by the pi pi. Yep. Okay, so that's the arc length. So the last thing we're going to look at is the area of a sector. So now in this formula, we're going to set up a diagram kind of like we did at the beginning, but we're not focusing on how long something is now. We're going to focus on the area that it takes up. And these shapes are sectors. Okay. I'm going to erase the shading because it's kind of hard to read if I leave these there. But what I just shaded in, that shape is called a sector. It's kind of like if you took like a round pizza and cut it up into 8 pieces, each piece of pizza looks like a sector. 2 sides are straight, the other side is curved. Just like I did before, I've labeled 4 things. An angle, an area, an angle, and another area. I just didn't have enough room to write the area inside that small sector. Before, we labeled an angle and an arc, and an angle and an arc. Now we're going to focus on the area. So when we're done, we're going to have a formula that says A equals, and then an expression that gives us area. All right. So first thing I have to mention about it is, again, angle size and area size are directly proportional. If you had an angle that was 90, that's the sector that it would take up. Now if you double that size of that angle, it would be how big? It would be 180. That's a 180-degree angle, and that's the sector. So when I doubled the size of the angle, did the size of the area double? Yes. If you make the angle half as big, you make the area half as big. So again, we can set up a proportion. So let's do that. So I've got four things, I've got four spots in the proportion, and I've got four things I need to plug in. A, theta, A1, theta 1. Like, lots of ways to set it up, as long as you set it up the same way on the left and on the right. Right? So could somebody tell me what I could put on the left? Sure?
Be A over theta.
Sure, could do A over theta. And now that he said that, you've got to set up the right side the same way he did the left. So what would I put on the top on the right side? Mike?
A1.
And then on the bottom?
Theta 1.
Theta 1. Right, so there's your proportion, because these are directly proportional. Now the problem is you don't have any numbers in that proportion. We've got to get that 1 foot 12 inches. We've got to get that starting fact. So we've got to have something to fill in right there. Okay, got to fill some stuff in there, otherwise we can't use it. So we're going to suppose again that theta 1 equals something. And just because we suppose it equals something, it doesn't limit like what we can do. If you're saying, well, how can you just suppose it is something? Well, how can you just suppose 1 foot is 12 inches? Because it's true. It's a true fact. So we're going to just suppose a true fact. And you don't have to do 1 foot equals 12 inches. You could do 2 feet is 24 inches. There's lots of facts you could start with. But we're going to try to start with the simplest one we can. So we're trying to get a connection between the size of the angle and the area that it takes up in a circle. Let's go back to these pictures. How big was this angle right here? This one was 90. So when you have a 90-degree angle, how much of the circle does it take up? That's a quarter. So 90 degrees, the connection there, 90 degrees, it's a quarter circle. What was the angle in the second one? That was a 180. How much of the area is covered in that one? A half. So 180 covers a half the circle. Well, let's take it a step further. How big is that angle?
270.
That's 270. So it's 270. And how much of the circle is shaded in now? 3/4. Well, let's go one more step. Let's go like this. Here's your initial. Here's your terminal. The two sides are right on top of each other. If you've gone all the way around and the initial side is back where it started, how many degrees did you go around?
360.
360. So if the angle is 360 degrees, how much area does that take up? The whole circle, right? Whole circle. So it's this last fact that we're going to use. If the angle is 360, or what's 360 in radians? 2 pi, yes. So if your angle is 2 pi, the area is the entire circle. Well, we should already know how to find the area of the entire circle. There's already a formula to do that. So all we have to remember is that formula. What's the formula to find the area of a circle? Yes, yeah?
2 pi.
So that's the circumference. So circumference is 2 pi, but it does have pi in it. Any other guess what the area is? Yep.
Pi r squared.
It's pi r squared. So here is the connection you can plug in. There's a connection between angle size and area size. If the angle is 2 pi radians, if the angle is 2 pi radians, then the area that that's connected with would be the entire circle. That's the connection. The angle is 2 pi, the area is the whole circle, and we just wrote down the formula. Now we've got some numbers we can fill in our proportion. But that's a true fact, and that's what we're going to start with. You could have started with any one of these other facts. You could have said, well, if the angle is pi, then the area is half a circle. You could have filled that in too. If the angle was pi, the area would be half of that. Right? But we just use, if it's the whole circle, it's the whole area. Okay? So leave these two on the left just the way they are. So A theta, and on the right, for area 1, fill in pi r squared. And for theta 1, fill in 2 pi. What I just circled right there, that's like in 1 foot, there's 12 inches. There's your starting fact. And you can use that to figure out anything else you want. So, goal is to get A by itself. A equals, and then we have a formula. In the part that I circled, is there anything I can do before I cross multiply?
Cancel the pi.
Yep, I've got a pi in the top, pi in the bottom. So the pi is gone. So now I just have this. And now I'm going to cross multiply. A times 2, which we normally write as 2a. Do that. Equals theta times r squared, or r squared times theta. I think the book puts it in that order. R squared times theta. Now, what we have right now is a formula for double the area. We just want area. So, how can I get rid of the 2? There's a couple ways. Yeah, divide by 2, which is the same as multiplying something by what? 1/2. Right? Dividing something by 2 is the same as just taking half of it. So let's just take half of what's on the left and take half of what's on the right. Half of 2 cancels out. It's 1. So you get a formula A equals 1/2 r squared theta. And that's the formula for the area of a sector. Okay, so A is area. What does R stand for?
Radius.
R is the radius of the circle. And theta is my angle. And what about it?
Angle in radians.
It's in radians. Okay. I did the same thing we did before. I suppose that my angle was 2 pi radians. So this is your angle in radians. And we pretty much do the same thing as last time. They'll give you 2 out of 3 letters, you plug them in, you find the third one. So we'll try a couple of those, and that's our last formula for today.
So that formula can be used on like anything to do with the sector, finding the sector.
Yeah. Any size sector, as long as you know the radius of it and how big of an angle the sector makes. Yep.
So it's either this one or it's the other one.
Right. It's either this is the formula for area, this is the formula for arc length. You'll know which one you need to use because if you read the directions, like in this problem, the directions say find the area of the sector, not the arc length. So you know you're using the one for the area. Okay, let's write it down. What's the formula for the area of the sector again? Yeah.
A equals 1/2 r squared theta.
R squared theta. Okay, and now we'll fill in what we know. Find the area. So you're not going to know the area. 1/2. Do I know the radius?
Yes.
Yeah. Yeah, I better, because if I'm finding the area, I can't be missing anything else. So the radius is 4. Squared? And what about my angle? Pi over 6. Is that in the right units? Yes, it is. There's no degree symbol on it, so it must already be in radians. So pi over 6. Right, so now just follow order of operations. Do your exponent first. 4 to the second power gives me 16, and then times 1/2. 8. 8 times pi over 6. I can reduce that a little bit. What goes into both 8 and 6? 2. So I end up with 4 pi over 3. Now, we're going to go back and see if we need a label. 4 pi over 3 is the what? It's the area. So I need a label on that if somebody looked at it right away, they would know that it's an area label. Centimeters squared, yes. So I can't always tell you whether it's centimeters or inches. You've got to go back in the problem and just look at the unit they used. Okay. So that's finding, in that case we had to find A. Any questions on finding A? Right. Let's try one where we have to find R. Now this is the one where the square root stuff is going to come up. So remember the two things. If you get a square root you can reduce, you have to do it. And if you end up with a square root at the bottom, we have to fix it. Alright, so the directions are to find the radius. How do I know whether or not I should be using the arc length or the area formula? There's something up there that tells you that. Yeah?
Well, you need to use the area formula because it's inside the answer, right?
How do you know that number, bless you, doesn't represent the arc length though?
It's squared.
Yeah, because it's inches squared, so it must be an area. So we got to use the area formula. So A equals 1/2. R we don't know. So we'll just put R squared. And now theta. Theta is 45 degrees, but what do I have to do? I got to change it to radians, and that's pi over 4. Okay, if you multiply by pi and divide by 180, that's what you'll get. All right, so there's a lot of things we got to get rid of. We got to get rid of the 1, the 2, the pi, the 4, and the squared. Let's start with the pi over 4. We can get rid of the pi and the 4 at the same time using a trick we already used once. How can I get rid of the pi and the 4 at the same time? Use the reciprocal. Multiply by 4 over pi, 4 over pi. Pi's are gone, 4's are gone. Pi's are also gone on the other side. So a lot of stuff just canceled out. What's on the left-hand side now?
843.
How much?
32 over 3.
Yeah, it's 32 over 3 equals 1/2 r squared. All right, so that's a little better. Now we want to get rid of that 1/2. We can do the same trick again. How do you get rid of the 1/2? Multiply by 2 over 1, or is it just 2 really? Times 2 times 2. If you want to think of it as 2 over 1, that's fine. That's gone. That's gone. 1 times 3, bottom just stays as 3. What about 2 times 32? 64. Now, I have a formula right now that says the radius squared equals 64 over 3. I want the radius. So what do I have to do? Take the square root. Take the square root on the right. And now when you square root a fraction, you do the top and the bottom separate. That's how you take the square root of a fraction. top, bottom. So now we finally have r by itself. And in the top, what's the square root of 64? So that one comes out nice. But the bottom, the square root of 3, can I take the square root of 3 and get a nice answer? No. So, other than the square root in the bottom, that is the answer. We just have to fix the square root in the bottom. Does anyone remember what you multiply by to fix it?
Just gonna retract that and take it back.
Square root of 3 over square root of 3. So at this point, we've done the part that I've taught you. Now we're just doing a little arithmetic to clean up the square root in the bottom. In the top, it's 8 times the square root of 3. What does the bottom become? 3. Square root of 3 times square root of 3 is square root of 9, which is 3. And that is my radius. Now, if it's a radius, does that need a label?
Yeah.
Yep, radius is a length.
Yes.
It's inches. Okay. You wouldn't want to put inches squared on that, because that means it's an area. If it's not an area, that's a length. So that's the hardest one. Okay. Any questions on finding r? Okay. So let's finish up with finding theta. So this time you've got the area, you've got the radius, find the angle. Carissa, what am I going to fill in for the left-hand side here?
The area.
Yep, we're going to fill in the area, which is how much?
Pi over 2.
Pi over 2.
Which is squared.
Yep, I'm going to leave the label off for now. When I do the calculations, I usually leave the label off, but I do have to put a label on the end if necessary. So I've got area. What comes after the equal sign? 1/2. Next thing? 3 squared. And the last thing is times theta, which I don't know. Now, my advice on the right-hand side is going to be just leave it as a fraction. Don't write it as a decimal. It's going to be more confusing. So, what's 3 squared? 9. And then half of 9 is just 9 halves. Just write it as 9 over 2. Don't even worry about what it is as a decimal. Just write it as 9 over 2. Because now we can use the same trick we've been using before to get rid of the 9 and the 2 at the same time. So how would we get rid of the 9 over 2? Use the reciprocal again. If you wrote it as 4.5, it would be really hard now to do this in your head. So multiply each side by the reciprocal. 9s are gone. 2s are gone.
Wait, I have a question. When you got rid of the 1/2, you did it times like 2, right?
So the 1/2
Yeah.
is right there. The divide by 2.
Okay, but wouldn't you do it on the other side too?
No, because when I do this out, I'm just saying it's 1/2 times 9 over 1, which is just 9. I'm just simplifying.
Okay.
Yep. So it's just 9 over 2.
I'm gonna write that down because I'm kind of dumb.
No, that's okay. It's good to ask questions.
I'm just being honest. Okay.
So now we multiplied by 2/9 and 2/9. Everything on the right canceled. So we have theta on the right. How about on the left? Does anything cancel there? 2's. And all I'm left with is pi over 9. That's an angle. I don't need a label on it because it's radians. The only things that need labels are R, S, and A. Those are the letters that need labels. Questions on that one? Alright, so in the homework, there's going to be a problem in the homework about a clock. Right? And it's going to ask you, as the minute hand or hour hand, however you want to think of it, moves, how far does the tip of the hand move? So the tip of the hand kind of makes what path as it moves? It makes an arc. So when they ask you how far the tip of the minute hand moves, it's an arc problem. Well, what would your radius be? If you're looking at a clock, it's the what? The length of the hand, right? If you're looking at the clock, the length of the hand is the radius. So they'll tell you that. Maybe it's 4 inches. But now the question is, you need the angle. Well, the thing about a clock is every number is equally spaced. So if you're exactly at 12 and then you're exactly at 4, we should be able to figure out the angle. There's 360 degrees all the way around the clock. And how many sections is the clock divided into? Yeah. So if you divide 360 by 12, it tells you each section is worth 30 degrees. 30, 60, at 3 o'clock it would be a 90, 120. So because each section is 30 degrees, you can figure out the angle. And the minute hand is the radius, and there you go. They're going to give you another problem about a pendulum swinging back and forth. Well, as the pendulum swings back and forth, the tip of the pendulum makes what shape? It's an arc, yeah. And the length of the pendulum would be your what? That's your radius. So they'll tell you, like, you've got a pendulum 1 foot long, swinging 20 degrees back and forth. How far is the tip of it moving? So it's another arc length problem. Okay? So just a couple of hints about some of the homework questions. So the homework is on the same page as last night. 71 to 87, just the odds. And 91 to 94, and that's all.